Hello, you are welcome to the Twitter Think channel, and in today's video I'll be talking about how to find the root of a quadratic equation, specifically polynomial functions. I'll be doing different kinds of examples under this topic, and before I move on to solve this question, I want us to find out how do we determine whether the nature of the root will be real or complex. Now, before we can be able to identify whether the quadratic equation or given to us will be real or imaginary or probably complex, it is very important that we understand what we call the discriminant. Now, I will explain this in just a few minutes. I have here the quadratic formula. Most of us have come across this formula: minus b plus or minus b squared minus 4ac all over 2a. Usually the quadratic formula here has something inside the square root here called b squared minus 4ac. This is what we call the discriminant. The discriminant is b squared minus 4ac, and it is used to determine the nature of the root of the quadratic equation. When I say the nature of the root, what are the values that you generate by the end of the day after you calculate or you finish your calculation for whatever quadratic equation is given to you? Now, let's assume that the discriminant is equal to d. So if d is equal to the discriminant, then let me explain this for us to get the concept. If we substitute the values of a, b, and c such that, before I do that, let me talk about this. What are a, b, and c? For instance, if I have a quadratic equation of the form, then this, I can compare whatever equation. Let me say this is equation 1. I can compare the equation 1 with a x squared plus bx plus c. And this is equation 2. So the value here is a, this is b, and whatever we have here is c. So when we substitute the values of a, b, and c into this formula, into the quadratic formula, we will be able to generate the roots of whatever equation given to us here. So now, when I come back to the discriminant, all I need to do is to pick the values of the a, b, and c and substitute it here. For me, usually what I do is that I only apply the quadratic formula when I realize that the root of the quadratic equation will be complex. For it to be complex, I just use the discriminant to determine that, because if it is not complex, then there is no need for me to use the quadratic equation. I can just use normal factorization to generate the root, or to calculate for the what? For the root. So when we substitute the values of a, b, and c here, if d is greater than 0, it means that the quantity inside the square root here is positive. And when that happens, the solution or the root of the quadratic equation after the calculation will be real, and it will be positive values. I hope you got that. I am saying that when you substitute the values of a, b, and c inside this one, when the quantity here is greater than 0, which is what I have here, if d is greater than 0, then it means the root of the quadratic equation will be real, and it will be positive values. Again, when we substitute the values of a, b, and c, and d is equal to 0, this means that the quantity here inside the square root will be 0, and square root of 0 is still what? 0. So when this happens, usually the plus or minus sign here does not play a part in the calculation, and what happens is that the solution of the quadratic equation would produce what we call a repeated factor. A repeated factor means that it will generate a particular value twice. So if the final solution was 2, then it will be 2 and another what? 2. If it is minus 2, then it will be a repeated number, twice of that value. That is what that means. And finally, if the values of a, b, and c are less than 0, if it is less than 0, then we have a negative square root. The quantity inside the square root here is negative. Therefore, we go into what we call the complex root. It means the root or the answers of the quadratic equation you have solved will be complex, or it will be imaginary what numbers. Imaginary numbers means that the left hand side of the solution will be real and the right hand side will be what? Imaginary. So this is what we call the discriminant. So we use the discriminant to determine the nature of the quadratic equation before we tackle it. And like I said, usually I apply the quadratic equation when I realize that the nature of the equation will be complex. Then I test it with what? The discriminant. Then I use the quadratic equation to do the calculation. So now let's get back to the question and see what we have today. So when we look at this quadratic equation given to us, it is going to generate complex roots. So we are going to apply quadratic formula. But before that, let's name this one equation 1, and let's compare equation 1 with ax squared plus bx plus c. So let's say this is equation 2. We have a being equal to 1, we have b being equal to 1, and we have c being equal to 1. So from the formula, we can quote that we have minus b plus or minus root of b squared minus 4ac all out of 2a. So we substitute the values of a, b, and c. Let's assume that the whole function is equal to x. X is equal to, what is b? Is negative 1. So we have minus 1 plus or minus root of 1 square minus 4 multiplying 1, and c is also 1. So we divide this result by 2 into 1. So when we continue this, we have x being equal to minus 1 plus or minus root of, now the root of 1 is 1, and when we multiply this, we have minus 4, or dividing 2. So 2 times 1 is 2. So now we have x being equal to minus 1 plus or minus. So now when we add 1 to negative 4, the result is giving us negative 3 all out of 2. You must know that during my introduction video, I said that root of negative 1 is the same as the imaginary unit. So we can substitute that here by saying x equals negative 1 plus or minus root of 3 times root of negative 1. Remember that root of 3 times root of negative 1 is the same as root of negative 3. So I can use that. I'm just trying to explain. That is why I'm doing this. All divided by 2. And I know that root of neg 1 is equal to I, which is what we call the imaginary unit. So I can say that x giving me minus 1 plus or minus root of 3 times I. I'm substituting this, all divided by 2. From the discriminant, we learned that if the value of a, b, and c is less than 0, this is what we get. We will generate a negative value inside the square root, and the result will produce a complex root, and this is what we are getting. But one is positive and one is negative, because we have plus here and negative here. So we have x being equal to minus 1 out of 2 plus 3i all over 2. Then this is x1, and x2 is giving us minus 1 out of 2 minus root of 3i all out of 2. And this is our final solution. In my next example, I'll take just another example under this, and then I will move on to other ways to find the root of quadratic equations. This is the end of this video, and I hope this video has been very helpful. You must read more under discriminant if you don't really understand that, and I would advise that you subscribe to this channel for more updates.